This is Dave, aka the Guru, and another tutorial on Gamesalad. This is our part 3 of our discussion of the physics engine. So now in this tutorial we're going to go ahead and look at how we deal some of the common issues that we have when using movable actors on a scene. So we've got our little player actor here and we've got our ground all set up. So we're going to build off of this a little bit and look at some of the common things that happen and how we deal with them. And there are different ways we can deal with things depending on what we want to do. And we'll look at some common things. So the first thing we want to do is we want to make some rules in here to kind of expand out our player's ability to move around. So I've got an accelerate behavior here for the right key. So I'm just going to go ahead and copy this, and I'm going to change this to the left, and I'm going to make that direction 180. And then I'm going to go ahead and grab this again, excuse me, and I'm going to go ahead and use the space bar for my jump this time. And I'm going to go ahead and make that direction 90. And I'm going to go ahead and let's just put this at, let's just say 400 for right now. And we'll uncheck this for now. And so let's go ahead in and just take a quick look at our little movement here. And so as you can see, we're getting some movement, but it's taken a while for the actor to kind of take off here. We're really, since we're using the accelerate behavior, acceleration kind of happens over time. Now we could use the move behavior, but the problem with the move behavior is it gives us more of a linear kind of a movement, and you really don't want that. It doesn't look like a natural jumping motion. If you use the move behavior, it kind of causes things to be the actor will go up and then immediately move sideways instead of naturally having an arc to it. So we're going to go ahead and we're going to do something using this apply max speed. So as you could see, we had an instance in there where it was moving up very slow. So let's go ahead and just boost up this acceleration to 1,000. Now we're never going to reach 1,000 in our acceleration, but what that's going to do is it's going to give us a really quick speed right off the get-go in our initial kind of before we would reach our max velocity. So as you can see, we're getting a much more snappier movement at the beginning here. But as you can see, it takes us off the screen way too quickly. Well, we can change that if we just come over. I've got a max speed applied at 450. So let's just go ahead and apply the max speed, and let's see what happens there. So we're gonna, and now you see we kind of level off, but we're getting a nice snappy jump, and our player actor is still going off the scene. So that's how we deal with that issue. Is we come down and we go ahead and we grab a timer, and we go ahead and set the timer to 4, and then we can say, all right, we only want this acceleration to happen for 0.5 seconds. We won't check run to completion because we want this to kind of be modified or change as we go on and off the space bar. We don't want it to be restricted, so if we push the space bar and we set run to completion, it would, if we hit the space bar again in that short amount of time, the timer would still be running, working off the initial setting. So we don't want that. We want this to be able to kind of jog. So we want the timer to respond with our space bar pushes. So now as we can see, we're getting the acceleration for a certain amount of time, and then it's cutting out, and it gives us that nice kind of natural fluid motion right from the get-go. And jump is still probably a little short, so we can go ahead, let's go ahead and boost this to say 550 on our max velocity, and let's see what happens. So we're getting a little bit of a better kind of a snappier jump, as you can see here. If we wanted it to take off a little faster, we could just go ahead here. Let's try raising this to 1200 and see if that doesn't give us a little bit of snappier. There we go. See, now we're getting a nice kind of snappier bounce from the get-go. We're getting a nice kind of high movement there. And we can go ahead and do a couple things. Let's go ahead and reduce this back to, let's say, 450 now and see what it looks like. And so there we go. We're getting a nice, that's a pretty good bounce right there. I'm not going to get too crazy with this thing. And so we can see that we're getting our timed bounce. Now you're going to see that if I just keep pushing the key, I'll go off the screen. I'm not going to get into that right now, but basically we would just make another attribute that would lock that out from doing that. So we would say, you know, you couldn't push the space bar again unless after you pushed it once, the actor hits the ground and all that kind of stuff. We're not going to go into that depth. There are other tutorials on the Academy and out there that show you how to build a platformer. I'm just kind of showing you how to handle the physics engine, and we're not going to get into all that. So let's go ahead and add a little platform here, which is, you know, usually what we have. We deal with certain instances in games and such, and this applies not only just to platforms, but it'll apply to any kind. All these things that I'm teaching you here apply to anything you're going to do in the Gamesalad engine. All this stuff is the same. It's just all attributes and movements and variables and behaviors, and you can apply these to any kind of situation you want. These are just some general ways you deal with this thing. You can use these same techniques in all kinds of things, not just how I'm showing you using specific examples here. The sky's the limit to what you can use these things, and these are just techniques that we're using to control movement, no matter what that movement is. So we have our little platform actor. So let's just go ahead and make this easier for myself. I'll open that, unlock the prototype. I'll go ahead and switch back to my tag down here. And we'll come in and we'll see, you know, this is pretty much the default. Let's get rid of the bounciness. We don't want that. And we'll just start with the defaults as then we can move forward and see the kind of issues that we can have. So I'm not going to hit fixed rotation right now because I want to show you how having that off, how that affects one actor colliding with another. So if we came over here, let's just say, for example, let's move our little actor over here. Whoop. That's one of the problems with using the accelerate behavior. So let's go ahead and let me go into my little dude here. And I'm going to go ahead and let me add some friction here. Let me make the friction like 400 and see if I can't get some control over his left and right movement. That is too much. I overshot my velocity, so I don't need nowhere near that much. So let's just go with 100 and see what happens, because my velocity was like 200. So there we go. That's much better. He'll slow down and control. So you can see how you just balance these things out. So now let's say this platform's here, and I'm colliding with it, and it's movable, okay, and I impact it. So I jump up, and boom, the thing's going to just fly away. And this is a common problem when people first start using Gamesalad. They set stuff up, and they go, oh, I've got this stuff movable, and I hit it, and it just flies around. So one of the first ways we're going to deal with part of this issue is we're going to come in and we're going to go ahead and we're going to check fixed rotation. And what that's going to do is it's going to allow this thing to stay on its rotation. It can be rotated using the behaviors now, but when in the physics engine, it'll be treated as one completely solid structure. In other words, it will no longer, in the physics engine, when it collides with other actors, allow the dynamics of that collision to cause this actor to spin on its axis. So now if we come in and we come over to the edge, okay, right now, and we go ahead and we jump up, you're going to see now it just stays as one solid rigid body. So that's fine. We've dealt with that first thing. Now, the other thing we want to deal with is how do we keep this little platform from moving along? So usually when we're doing a platform like this, we're usually doing a specific type of movement with a platform. So it's usually either this platform will kind of be moving up and down, and then you have to time it to jump on it, or it'll be moving left to right, and it'll always stay on those positions. So we're going to go ahead, and one of the first things that we could do is we could go ahead and just grab a constrained attribute like this, and let's just say we're going to make this little platform move up and down. So what we would want to do is constrain its X position. So this will keep it fixed at that position. So just for the example I was doing, let's just constrain the Y so I can show you that. So we'll go ahead and we'll say the platform's self-position Y, we're just going to fix it to its position that it's at now, so 346. So now that we have that, we'll go back in And we'll go ahead and move our little actor over. And we'll go ahead and jump up, and bam, as you can see, we can't push it up any longer. But it still is moving this way. So one of the ways that we can avoid kind of having more influence over pushing it is we could come in and then shoot up the density. So let's go ahead and make the density like 300. Let's see, because density and its movement is going to be based on how much velocity we're at when we're hitting it. So let's kind of see how that, and as you can see, now that we've increased the density of the object, it no longer gets knocked off on that X position, but it's still going to be movable. So now, as you can see, is we've got this pretty solid now, and you may have, depending on how much velocity you have on your player actor moving up, you may have to increase the density more to be able to match that velocity, because it's basically the impact speed that we're working against. So the higher the impact speed, the higher your density wants to be. And so now let's say we want to kind of move this platform. Let's just go ahead and shrink this platform down a little bit. And let's go ahead and let's just say we want to move this kind of left and right to jump on it. All right, so now let's move this. Let's make this actor move here. And we're going to go ahead and we'll make a couple of, I'll make a self attribute here. So let's go back to the prototype, and we're just going to make an integer, and I'm going to call this trigger. And so what I'm going to do is I'm going to trigger this to move back and forth, because I want to keep all the movable situations intact. I could interpolate this back and forth, but that would really take it out of the physics engine, and I don't want to do that. And so here's one way we can deal with that. What we want to say is, let me go back to the prototype, a non-prototype, or the scene actor, now that we've got our self attribute in there. So what we're going to say is, we're going to say when attribute platform position X, and we want to make it equal to or greater than. And the reason why we're going to do that is on the left hand side we've got 596. So this will be the movement. Whoop, why did that? 596. And the reason why we're going to do that is because when we're using real attributes like position and the pixels, we're going to have decimal places in there. So if we used an equal sign, that would mean it would have to exactly equal 596 with all zeros on the opposite side of this. And usually, more than likely, when you're moving pixels, you could have 596.0001. That's not exact. It does, so we're not saying self position X does not equal 596. It equals 596.0001. And this is where people get hung up on. And so it causes things to not work consistently. So by using greater than or equal to, basically we're going to allow the actor to kind of move to that 596 and then go over a little bit on the decimal places. And when it reaches that, anything over that, we're going to go ahead and trigger it. So if we just went over and we threw, let's say, a move to behavior in there, what's going to happen in the condition in this rule is, even if we set it to run completion, it's just not going to work right, because this condition, as soon as we start moving back the other way, is going to become invalid, and this move to behavior is going to stop firing. And we don't want that. So what we're going to do is we're going to go ahead and we're going to conditional this thing out. So let's go ahead and just make another rule, and we're going to say less than from the other direction, and we'll go to 200 on the other side of the screen. So we're going to move back and forth between 200 and 596, and it's the same operation here with the 200. We'll let it go over to the left a little bit past the 200 into decimal places, and then we'll go ahead and trigger things. So what we're going to do is we're going to go ahead and, instead of putting the behaviors necessarily in these two rules, we're going to go ahead and create some conditions, and then we're going to go ahead, and what we're going to do is we're going to change that self attribute. So we can go ahead and say self, and we're going to say the trigger, and I'm just going to copy this. And so we can go ahead and say when When it equals this, let's go ahead, since it starts out at 0, we'll just go ahead and change that to 0, as that's the first condition. So it's going to start on 0, and we want that to start right away. We're at 596. Keep it at 0. We want it to move over, and then when it gets over to the other position, we're going to go ahead and change it to 1 and 0. And the reason why I like to use I like to use booleans. You know, some people like to use booleans. I'm not a big fan of them because they can cause loops and all that. I like to use integers because then I could also build out neutral positions, and I could add more movements in here just by changing this number. Gives me more flexibility when I'm coding. And so now what we want to do is, now that we've established the movement between 1 and 0 between our actor, we can go ahead and add another rule now. And we can come in and we can say when attribute self trigger equals 0, let's go ahead and tell this actor to move. So let's go ahead to the move, and we can do a move too, so we get a precise, and we'll say move to position, and we're moving to 0, so we're moving to position 200 on the X. We don't need to do anything on the Y because we're already constraining it here. We can just leave that at 0. And we'll make the speed 200. And then what we can do is we can go ahead. We don't have to add another rule in here. We can just use the otherwise condition in here. And we'll say move this to 596 in the other way. And we won't check run to completion here. We're going to let this play out. And let's see how this works out for us. So let's just go ahead and save it. And we'll go ahead and come into this, and we'll see we get our platform, and there it goes. And when it hits there, it moves back. And then when it hits there, and we got a nice platform moving back and forth here on this position with a good density and all that. So now we should be able to time this, jump our actor up, land down on the platform. But as you can see, he falls off. So let's get up there, and let me see if I can land on this thing. So there, now I'm landing on it, and you see I'm sliding right off. So let's go ahead in here, and let's get some friction going on here. So I'm going to go ahead and just slam this at like 500. And let me just check the friction on this to make sure I'm in a positive value. And friction is 100. I'm just going to go ahead and change this to 3, just because I only want to be dealing with one side of the equation as to adjusting my friction. So let's go ahead and time this to jump up and come down on our actor. And now you can see we're sticking a little better to the platform of our actor. And let's go ahead and see if we can, let's go ahead and boost this to 700. See if we can just get a little better sticking on there. See when we, and so you can see we're getting a little better. We can actually boost this up even more. Let's go to 1,000. And we'll go ahead and wait for it to go by. And we'll jump down. And now he's still kind of falling off there with the friction. And let's see when we hit, yeah, see, you know, we're getting into the collision where it's really sending us over the edge. I'm going to just really run this, see what happens, see what we can come up with. See how this works for us. There we go. Now we're getting a little better. And it could actually, since it's multiplied, we might want to go into our other actor and boost this up. Let's go ahead and make this friction 20 and just see how that helps us out. So we jump up, get on there. And boom, we've got a nice, we're riding on there. And we're not really falling off too quickly. And we can still, now see the issue you're going to have is now I'm trying to move left and right. Okay, so I've got good friction on there, but really what friction's doing is, and a lot of people when they get on platforms, they want to be able to kind of move on the platform. And if you put too much friction, it's going to inhibit your actor from moving back and forth if you want him to move on the platform. So I'm going to show you a way right now that we can go ahead and ride this platform without having all this friction. So we'll keep a little bit of friction on there, and we'll just go ahead and do 100 because it does help. And that should keep us, let's just test it out. I'll get up there and ride on it for a second. I want to just kind of test it, make sure I can move with that. And nope, it's not. Oh, you know why? No, that shouldn't be it. And so let me go ahead and reduce this down to 50. And let's see what happens. Yeah, see, I'm moving on it now, okay? Moving back and forth on that actor. It's because I've got my velocities. I've got this. Let me slow this down. That's the problem. I've got a speed of 200 and I'm moving at 200. So let's move that at 100. Let's move that. This is where you really have to balance things out. That's why you really have to plan, because I'm moving at a velocity on that actor. And so now I'm able to, as you can see, I'm able to move on the platform. And you would want these settings higher on there as well. It's a balancing act that you really have to go in and plan it all out. But let me show you how to constrain kind of a position. So let's go ahead into at the game level. And you can see I've got a velocity X and Y here that I had already created for some other stuff. And we'll go ahead and use that. So we want to track, what we want to do is of this platform, we want to go ahead and track the X velocity of that actor. So what we'll do is let's make a rule, because we don't want this, when we have constraints and we're tracking and stuff like that, we don't want that stuff running all the time. We only want it running when we need it. So let's go ahead and make a rule, and we'll see when actor receives events, overlaps or collides with our player. And what this really is going to do is allow us to build really a really efficient thing. So we can we only would, since 99 times out of 100, our actor can only be on one obstacle at a time. We don't need to go for every obstacle and make, if we have 20 obstacles, we don't need 20 velocity X attributes. All we need is a trigger that's going to tell when we're on a specific object to start producing information to that one variable. And so what we're going to do is we're able to really slim the code down by doing it this way. So we're going to go ahead and we're going to come in here, and we're going to say when you overlap and collide with the player, we're going to say we want you to constrain your velocity to that X attribute. So we'll say constrain game velocity X to the platform's motion linear velocity X. So only do that when the player is touching you. Okay? Other than that, don't fire. And we could have this same rule in all our other platforms, and that allows us to only have a need for one attribute instead of a whole bunch. So then what we want to do is we want to come into this guy here, and we're going to make a rule. And what we're going to do is we're going to say in this rule, we're going to say, and usually I might make something with the one condition where all the buttons are down, but I'm just going to do it this way since I only have two conditions in here for movement. So I'm going to say when attribute keyboard left is up, and when keyboard right is up, I want the actor to now, so in other words, I'm not trying to move anything. Okay, and if you have a whole bunch of different commands like jump and all that, you can just go ahead and make one rule, and just have like when left and right is down, also trigger an attribute to change the number, and then you could just monitor that one. So we're going to go ahead, and what we're going to say is when it is either one of these are true, and also what we want to say is when actor overlaps or collides, and we're going to use the tag. We can use the tag for, it makes it easier than saying all platforms are all movable objects. So we're going to say when it's under the collide tag, and this is where tags really come in handy to kind of group everything. It saves us from having a whole bunch of other conditions. We're going to say constrain attribute self motion linear velocity X to game velocity x. So let's just see how that works out for us. I'm curious to see how the timing works out if it starts reporting and does that. And see if we can get a nice stable ride on our platform here. And we're getting a pretty decent ride on our platform. We can still move. I'm still moving on that platform with 100, as you can see. So if I increase my movement here a little bit on my player, and let's come up into these rules, and let's just boost this. Let's change this to 300 from my left and right movement. And we'll jump up, and we'll get on there. Oop. Oop. Let's move this way. There we go. Let's get on there. There we go. And you can see now I'm moving on the platform. And you can see we've got a pretty decent stable movement on there, tracking with the velocity. And you can see we also, we're losing a little bit. So we could also go in, and another way to deal with that is when we're tracking the velocity, we could go say game velocity, and we could multiply it. So we could say times 1.5. So we could give it like a little bit more juice going in that direction to compensate for anything. So we can get on there. Let's get on there and see how that works. And we can see we're going a little bit ahead with that 1.5. And let's go ahead and we'll say, let's just multiply it. Let's just add. Let's add 20 to the velocity. See how that works. Get in the middle here and see how that works for us. And we can see that, just by adding that little bit of extra on there when we're colliding, it gives us a little bit more stability on the platform as we're moving left and right. So as you can see, it's just really a matter of going in and making these minor little adjustments, balancing everything out, balancing out your friction in relationship to the velocity that you're moving left and right, and balancing out your speeds and all those kind of things. But that's pretty much consistently, even though we're bumping back and forth and moving back and forth a little bit, it really is keeping us on the platform as well, moving a little bit in each direction, but we're tracking the velocity. And so, there you can increase and mess with this and work with it until if you wanted your player to be like really stable and not move around at all when they're on the platform, you could just keep tweaking these until you get the right balance so everything feels natural and moves natural. But that's one of the ways that we really begin to work with moving objects in Gamesalad and keeping them movable, and starting to deal with addressing some of the different aspects or problems that we run into as well. So in the next video, we'll look at some other types of movements, and we'll look at ways of constraining velocity and all that kind of stuff, instead of just straight constraining actors like this, and then using movable and stuff with density. We'll look at some of the other ways. There's other methods that we can begin to address some of these other issues, and everyone kind of plays depending on what you're trying to do. Each one has its pros and cons, and so you kind of assess what you're trying to accomplish, try the different methods, make the adjustments until you find the one that works for you. So anyways, this is Dave the Guru, and I'll see you in the next video.